So, in this episode, I want to go over what system design is. There's a cheat sheet, which is linked in the show notes that I think is really going to help you. My buddy Zubin, who did pass the interview at Google and wrote an incredibly popular article on it, is linked in the show notes, along with my cheat sheet that's going to help you out no matter if you're going for interviews at Google or the local startup. So, before we get started, what is system design? Well, it's designing a system, you dummy. But really, it's a style of interview where the interviewer will ask you to design a large software system. You'll start with the UI. You'll think about the database layer. You'll think about the API layer. You'll think about caching strategies. You'll think about basically, how do I make this thing work? What you're asking me, how would I design the whole thing out? You'll usually draw it on a whiteboard, or now that most interviews are remote, you'll use something like Excalidraw or some sort of tool where you can draw like boxes and shapes and arrows that will point to different pieces of the system. These are not easy interviews to approach, and they're so different than what most people are used to, because what you're used to doing is writing code on your machine. And those interviews are tricky enough. There's a whole industry dedicated to helping people beat those kinds of interviews. Now, system design is more of conversation, and these are harder to cheat on. They're harder to just fake. And so you need to know how to approach them, which is what we're going to go over today. They're also, in my opinion, the most high paying type of interviews. What do I mean by that? I mean that if you're going to a system design round, that can either up level you or down level you. The expectation for somebody that's a manager is that you have really good system design skills and you actually don't maybe have that great coding skills. It's not uncommon to go into an interview as a manager where they say, we're actually going to skip the coding questions. We're not too concerned on how you do on like the leap code style portion of the interview, and more concerned about how you design the system. System design is where leaders are expected to have a lot more knowledge and skill. And this is also where most people fail, because they treat it like they treat the coding in it. So there are so many articles out about this stuff that you can just read about all the different types of system design interviews. What I'm going to go over, though, is an approach that will help you and has helped me go from zero to system design hero. I went from failing a bunch of them to recently getting a few offers. And in one interview where I failed and actually didn't get an offer, I was really ecstatic because they called back and says, "You did really well on the system design round." I failed the leak code style portion of it. They said, "Wow, we got really high marks on the system design." I'm like, "Oh, great. It's working. It's working." And then the job I just got offered for, it was out of 30 people, and I kind of won the game. I talked to the interviewer at the end of it now that I'm on the team, and he says, "Yeah, after 30 people, like, you were the only one that really passed the system design round." And I thought, great. Okay, so I'm on to something here. My hard work is paying off. So let's go through it. But before we go into that advice, I just want to give you some real basic foundation in system design, because there's some concepts which you're going to want to familiarize yourself with so you can mix and match these different features and components of a system to combine them, kind of like ingredients in a recipe. So I'm going to name off some things, and you may not be familiar with them. That's the thing. You can go online and learn all about these different things, and they're in the article that is posted at the bottom of the show. But I don't want to get too deep into the technical piece, because that's something you can honestly learn anywhere. I want to go into the stuff that's not so easily learned, that I had to learn over years of mistakes and dozens of interviews. So here are the buckets of technology you should familiarize yourself with before you even consider studying for system design or going into a system design interview. You need to understand things like databases, SQL versus NoSQL. And when I say understand them, I don't mean have like really deep knowledge of them. I mean just be able to explain what is SQL and what is NoSQL. Why do you use something like Postgres or MySQL over something like MongoDB? Or maybe something like Elasticsearch. What about vector databases? Familiarize yourself with, 3 to 4 different types of databases, SQL and NoSQL at a minimum, and be able to explain the trade-offs and when one would be appropriate to use over the other. And I'll have an episode on this in the near future, because this is a actually pretty interesting topic, and it's something that can make you think about, oh, why are we using this type of database, and which database is the right one for the type of data that I want to capture. Next, you should learn about caching and distributed caching. When it comes to distributed caching, just look up Redis and read a little bit about Redis. There's some white papers out there on Redis and distributed caching, and knowing a little bit about that can make you pretty dangerous, and it's just kind of fun to learn. It's an interesting topic that is very, very common in your system design interviews. Okay, next we have message queues. Learn what are message queues. Basically, message queues are used when you want to have a process that can take place in the background without blocking other processes. Think about uploading a YouTube video. When you upload a YouTube video, if you ever have, then you'll notice that it will tell you, like, hey, it's processing, and it will let you know when it's done processing. So that might be happening in a message queue. Basically, it won't be blocking what you're doing on the screen from happening. It'll have that process take place somewhere else that is not blocking other processes from running. But learn about message queues. There's a few out there. There's RabbitMQ, there's Kafka, and I think Amazon Web Services has something called SQS, if I remember correctly. But look up, what are message queues. Next, look up CDNs. These are content distribution networks. Basically, how do you have a file or set of files or some sort of code that may be propagated or spread out among a bunch of different servers? Like, maybe you'll have the same file on multiple different servers. And why would you want that? Well, maybe one of your customers lives in Africa and one lives in the Netherlands. Should they be both looking at the same server to find the same, image that you have on your website? Probably not. Most images are hosted on CDNs, content delivery networks, meaning that when you're in Africa, you're looking at that image on the server that is closest to you, while if you're in the Netherlands, you're looking at the server that is closest to you. This is a really common concept, and one that I think a lot of newer developers don't really think about or know, because nowadays all the libraries you use are installed through NPM. Back in the days, you used to have a script tag, and it would have some sort of address to a CDN to get something like jQuery or AngularJS or even React, which was actually a not so uncommon way to install React, was by having like a little script tag and having the URL, which would point to a CDN where you'd fetch that entire library. Next, this one is more of an advanced topic, but you can learn about database partitioning. Basically, how do you split up a different table in your database so you can break up the same table and make it multiple of the same one. So essentially, how do you decide, if you have a massive table and you want to look through it really, really efficiently? How can you partition it? How can you split that data up? This topic honestly has always confused me a bit. And I think that if you're getting into this direction in your interview and you don't know a lot about database partitioning, maybe just don't bring it up. And I'll get to that one in a bit. I'll get to kind of like how I approach system design interviews, because I don't know all these topics really, really well. I know a few of them, and I know how to mix and match things to make them work. And lastly, CAP theorem. CAP, CAP, stands for consistency, availability, and partitioning. Essentially, it's this theory slash rule that you can have two out of three of those things. So you can be consistent and available, but you can't use partitioning, or you can be consistent and partitioning, but not be highly available. Look up CAP theorem. There's tons of articles written on it, but it will give you an idea, like a really high level guide on how to construct your system, and also know the trade offs and what you can and can't do according to this theory. Okay, now let's get down to the actual way you approach these interviews. So you have this knowledge, you've read the articles at the bottom of this show, you've checked out the show notes, you've checked out Zubin's article that he's written on this, you're ready to go. That's not what the system design interview is about. I painfully learned this. It's not about getting the right answer, it's about how you think. This is not a pop quiz. So, yes, learn all these different buckets of information, but understand that you're entering into a conversation. When the interviewer asks you to design a rate limiter or a messaging system or Uber for cats or something dumb like that, they're trying to see if you can do more than just draw boxes in the same way that the book did. They really want to know, can you ask the right questions? Can you talk about the trade offs? Can you explain why you chose X over Z? Can you explain? Will you change your mind if new information comes up? And can you model the problem before you just start throwing a bunch of buzzwords and tools at it? I didn't do any of this stuff. So I came in there I didn't do any of this stuff. I came in there just guns blazing, like design Twitter. And I'm like, boom, I remember that from the book. And I'm starting to go through all these different things that I read in this book from Alex Zhu, XU, by the way. Again, excellent books. I'm not sponsored at all. I don't think Alex knows I exist, but really good books. And you should read them absolutely, because they're really short and to the point and tell you how to approach 90% of your system design interviews. But again, these books won't just make you pass them. Here's what the book doesn't teach you. Context is everything. Let's think of an example like having likes on a social media app? Do they need to be accurate to the second? Probably not. Do they need to be accurate like at all? Could you have 10 likes if they had 12? Does that matter? If you have a million and you show 1,000,003, does it matter? Maybe not, maybe so. This is something you want to discuss with the interviewer. But in my mind, it's probably not important to have these accurate up to the second. You can like batch process these every few minutes, and 99% of your users won't notice or care. That's not what I would consider bad engineering. That's just being smarter and more efficient. Or let's say your or let's say your system design or let's say your system design involves creating an internal dashboard for people within the organization. Are you going to spin up some really complicated API layer and database layer and think about caching strategies and all this kind of stuff for 10 people in your marketing department? Probably not. I mean, you could, but should you? No, you shouldn't, right? So you need to think, what is the actual ask that I'm being what is the actual thing they're asking me to build, and what are the right tools for it? Sometimes in the books that you'll read, it's like everything is built for these billion people organizations or whatever, or apps that serve a billion plus people that are at world scale, they call it. But if you're not building stuff for that, why would you want to use those approaches? So here's what I do now and what I've done recently that really, really works. So once I got over this memorization phase and I realized this was a lot more about communication, it really changed how I approach it. So here's how I approach it now in a step-by-step process. One, start with questions. Ask a lot of them. Don't skip on this part. Don't think you're being annoying. You want to ask questions. These interviews are typically 45 minutes long. One of the biggest red flags in my earlier system design interviews is that I was done with them in like 20 minutes. And I was like, oh, I think we're done. No, I didn't ask nearly enough questions. Ask lots of them. How many users will we have? Who are the users? What matters more? Cost, speed, consistency. Interview your interviewer. Say, what are we building? For who? Why does this matter? What are some things that I need to know about this system? What are some things that you think I should know? Always ask them. And if they push back a little bit, that's okay. You kind of want to go up to the point where they push back and say, okay, I think we're done with this. Let's move on. Now, you don't want to spend too much time asking questions. Obviously, there is a time limit on these interviews. But if you're getting through this in like a minute, that's way too short. If you're taking 20 minutes, it's probably too long. So spend around 10 minutes in this section to really get an idea of what you are building before you even touch the screen. Now, step two, model the flow first, not the tech. So go through a series of questions like what happens after they log in? What happens after they post a message? What happens when they like a comment? Before you just start saying, well, I think we should use Redis for this and NoSQL for this, just make sure you understand the actual flow. Just write it out. Then you can begin modeling some of the data in this step. You're like, okay, we have likes, we have users, we have maybe a login system. Does that matter? Okay, we can forget login. We have users and we have likes and we have posts. How are these related? Okay, it looks like this is the kind of data we want to capture. And you can just write this out. And you could say, maybe we'll model this using Mongo and NoSQL. Maybe we'll model this using SQL. And then you can explain why you would choose one over the other. So before you start reaching for the tools, think about what actually needs to happen in the system, write it out, sketch it out, and then you can begin inserting your tech where it makes sense. Step three is to know your toolbox. You don't want to be the person that just pretends to know everything. So I tend to center my interviews in the areas where I'm the most familiar. And I'll even explain to them, here's the areas where I'm less familiar. I'm less familiar with like database architecture. I'm more familiar with the API layer and the front end. So I'm going to spend a little more time there, but we can absolutely go into these other areas. I'm very upfront about that because I'm not going to fool anybody if I just start rattling off words like, we're going to partition this index in this database and they ask me more questions. I'm kind of screwed. So I don't want to go too far down that road, right? But you should be able to explain at least some of the basics and the trade-offs. You should understand what data partitioning is at a high level and why it might be a good idea to use at some point. So you don't need to know everything, but you need to know at least what the tools are good for. Should you use a relational database versus NoSQL? Should you have a caching layer? If so, what should the caching layer be? Are you using a queue? If so, why? Are you using a CDN? If so, why? Have a basic understanding of each thing so you can reach for the right one when it makes sense to do so. Step 4 is to invite feedback. This one is really, really important and can actually save you from going down the wrong track. And I was really afraid to do this at first because I was like, I don't want to sound dumb. And I tried to have all the answers and I thought maybe it's not appropriate to ask this kind of stuff. But here's the way I approach the last few that I've done. I would say, here's the way I am thinking about this, but I'd love to get your input before I go any further. What do you think about this approach? Is this something you think makes sense for our current use case? Or should I try to maximize for scale? Or should I maximize for speed? What do you think about this? Sometimes they'll say, I think that this is okay, but we can revisit this later. And that's a good sign that, okay, I need to think of a better solution. Or they can say, no, I think this is actually great. I think we can actually move on to the next section. And you're like, great, now we can move on to something else. And this is showing collaboration. It's showing that you're open to feedback. It's showing them that you're actually thinking and not just rattling off some script. Now, AI tools can't just do this kind of junk yet. So you can't just pass this off to an AI and be like, what do you think? It's going to give you basically one of the answers that you get in one of these system design books. It's not going to think through the actual trade-offs or talk with your interviewer. Remember, this is a conversation. This is something that you should be good at as a human doing, or at least maybe a little bit better than AI. Okay, the last step is be ready to change your mind. This kind of goes back to step 4 when you're inviting feedback. This isn't a trick, right? This is just real life. If you're actually designing a large system, you should be ready to change your mind given more information or better information or new information, or just change your mind because you have a better solution. If the interviewer is pushing back and says, why don't you just use NoSQL? You don't need to get defensive. You can say, yeah, you know what? That's actually a really good idea. Or you can say, you know what? I was considering that, but I think that this is actually better because of this reason. What do you think? Is there a reason why you'd prefer something else here? That can lead to an interesting conversation, some healthy dialogue, instead of just saying, oh, yeah, whatever you want. Sure, buddy. If you're interviewing for a position where they want you to think at systems levels, then you need to be able to push back, defend yourself, and also change course when it makes sense. This is not a weakness. This is senior level thinking. This is what leaders are expected to do, and just people working on a team. You can't work on a team if you don't know how to respectfully push back, and you don't know how to also take criticism and then move with that into a different direction. So the last takeaway, which I hope is clear by now, I lost these interviews because I tried to memorize. So the real takeaway, which I hope is clear by now, is that I lost those previous interviews because I tried to memorize my way through something that's supposed to be a conversation. This is exactly why in our program, the Inner Circle at Parsity, we have people get on camera to explain topics. We talk about things in depth. We push back on our students when they're building something. We ask, why are you using this? What's the point of this? We don't do it in a mean way or to criticize. We genuinely want to know, and we also want to prepare them for how to defend themselves. So when you present a project to me, for example, and you're in Parsity and you're saying, I want to use this technology and this, I'm going to ask, well, why not this? Have you thought about this? What about this? And if you can defend it, great. And if you can't, maybe I've given you a different direction to go into. It's also why we do a lot of mock interviews, because we see that people tend to fail at these. Now, if you're really junior, you're less likely to get these, but you're way more likely nowadays to get system design in your interview as a junior or mid-level than you ever used to be. It used to be only for senior and above, and now it's becoming more and more common for junior and mid-level roles to get these system design interviews. Why do you think that is? Because if you can do most of the coding with AI, then where does your real value lie as a developer? It lies in like this more architectural thinking and thinking, okay, how do I compose systems? How do I make systems that will scale and work for the company if my little AI robot can code a lot of the trivial stuff that I don't really need to do anymore? So this is a reason why you want to get pretty good at this skill, especially if you're trying to go from mid-level to senior level at any point in your career, which you'll pretty much have to be. And if you want to get senior plus level, forget about it. This is basically all your interviews are going to be this type of interview. So the next time you're asked to design something, don't think about the perfect answer, talk through it, explore the trade-offs, think like an engineer. Really hope that's helpful. Check out the show notes for the 2 articles that are in there. One's a cheat sheet, one's an article by Zubin that's going to walk you through really in depth on the technical side. And mine is more of a simple cheat sheet you can use the day before your interview if you're really in a rush. Hope it's helpful. See you around.